Hey everyone, welcome to The Explainer. I am absolutely thrilled to have you here today. If you're an engineering or technology student, you know for a fact that building the future isn't just about drafting incredible 3D models or writing elegant code, right? It is really about navigating the chaos of the real world. So today, we're going to forge what I like to call the engineer's shield. We're going to visualize exactly how to tame risk and uncertainty in your projects, all so you can protect your team, your resources, and of course, your final product. Here is our visual syllabus for today. 1. Intro to project management. 2. Risk versus uncertainty. 3. Risk management process steps. 4. The risk assessment matrix. 5. Site safety inspection scenario. And finally, 6. Subtopic review quizzes. All right, section 1. Intro to project management, the blueprint. Okay, let's dive into this. Because before we can protect our project, we really have to understand what it actually is and why it desperately needs managing in the first place. You see, a project isn't just some run-of-the-mill daily task. It's a unique set of coordinated activities, and it has a definite start and finish date. And because every single engineering project consumes valuable resources, project management becomes that absolutely essential discipline of organizing those resources to deliver the work within very strict constraints. We're talking scope, time, and cost. Without this blueprint, things are going to spiral out of control fast. Moving right along to section 2, risk versus uncertainty, the unknowns. Now that we have our blueprint, let's pivot our energy to the elements that actively threaten our project's success. This is absolutely crucial to understand. We have to know the difference between risk and uncertainty, because in engineering, we treat them very differently. Risk is measurable, and it's controllable. We can actually assign a probability to it. We know the chances of the outcome. Uncertainty, on the other hand, well, that's completely unknown and unmeasurable. Think of a sudden, unprecedented tectonic shift that destroys an unbuilt site foundation. We just can't assign a probability to that. The takeaway here? We can manage risks. We just have to survive uncertainty. Okay, let's test that right now with a rapid micro-quiz. If an engineering event has a known 20% chance of occurring and it can be minimized, is it a risk or an uncertainty? Got it in your head? The answer is a risk, because we have a specific probability, that 20%, and it can be actively minimized or controlled. Which brings us to section 3, risk management process steps, the playbook. Now that we know we are dealing with measurable risks, we need a solid methodology to combat them. Let's look at the playbook managers use to shield their projects. So, here is your systematic 7-step guide to risk management. It all starts with establishing the context of your project so you can properly identify the hazards. Once identified, you analyze and calculate those risks to figure out just how dangerous they really are. Then, you treat them, meaning you decide exactly how you're going to handle them by creating actionable plans to eliminate or improve the situation. And finally, you implement those plans in the real world, continually reviewing and evaluating to make absolutely sure your shield is holding up. Section 4, the risk assessment matrix, the tool. We've seen the playbook, but how do we actually calculate and analyze those risks? Let me introduce you to the primary visual weapon in the engineer's shield, the risk assessment matrix. It literally all boils down to this one fundamental equation. Risk equals likelihood multiplied by consequence. Or to put it even more simply, a hazard's danger is just the product of how often it might happen, multiplied by how bad it'll be if it actually does happen. Now, what's really interesting about this matrix is how that equation turns into a vibrant, color-coded map. On the vertical axis, we're gauging the consequence, ranging from superficial all the way up to catastrophic. Across the horizontal axis, we plot the likelihood, from very unlikely to very likely. By cross-referencing these two factors, your hazard lands in a green, yellow, orange, or red zone, and boom, that instantly reveals your true risk level. Time for another quick cognitive check. Imagine that matrix we just looked at. If a hazard's severity is merely superficial, say no treatment is required, but it is very likely to happen, what is the resulting risk level on that matrix? Lock in your answer. It is moderate, which was sitting right there in the bottom right corner in orange. All right, section 5, site safety inspection scenario, the field test. You guys are doing great. Now let's shift from theory over to practice. We're going to adopt a highly tactical mindset and apply these matrix concepts to a physical, real-world construction site. Whenever you're writing up a formal risk assessment document for a site, you follow a very precise flow. You start by identifying the physical hazards and listing exactly who might be affected by them. Next, you use your matrix to rate the initial risk before any safety measures are taken. With that baseline set, you apply your control measures to fix the problem. And finally, you assess the residual risk to see where your danger levels sit after those controls are actively in place. So here is how that translates to a real site. Take slips and trips, for example, which affect both employees and visitors. Initially, this is a high risk, but by implementing strict tidiness and immediate spill cleanup as our control measure, our residual risk drops all the way down to low. Or consider poor lighting for employees, an initial medium risk that drops to low once proper lighting is actually installed. This flow proves you are actively protecting your site. Section 6. Subtopic Review Quizzes. Let's move to this final section and see how all of this builds together. It's time for a rapid-fire, gamified review sequence to really solidify everything you've learned today. I'm going to throw 3 questions your way. Question 1. Think back to the core purpose of all this paperwork and planning. What is the primary objective of doing a risk assessment for any engineering activity? Lock your answer in. Moving to question 2. Picture that colorful 2D grid in your mind. In a risk matrix, how is the severity or consequence of the risk typically shown to be increasing? Which direction on the graph? And finally, question 3. This one is about your legal and ethical responsibility as an engineer. According to the law mentioned in our site safety scenario, what must you do with the conclusions of your completed risk assessment document? All right, let's validate your learning for question 1. The objective is to reduce risks to the health and safety of everyone affected. Simple as that. For question 2, severity increases vertically up the y-axis. And for question 3, the legal requirement is that you must show the assessment to the affected persons and get them to physically sign and date it, proving they understand those safety controls. As our source material wisely notes, if you have no hazards, then you have no risks. But that seldom happens. Engineering is inherently hazardous. We build bridges, we wire power grids, we develop massive software architectures. And because it's hazardous, proactive project management is absolutely non-negotiable. Which brings us to our final thought today. You now possess the blueprint. You know the steps, you understand the matrix, and you know the law. So I'll leave you with this. Now that you know how to build it, how will you use your engineer's shield to protect your very next project? Thank you so much for joining me in this explainer. Stay curious, stay organized, and go build something incredible, safely.